So we can also loop through dictionaries as we just said. Okay, so let's create a dictionary with so this is again we're going to look at we're going to have some more compound interest fun. Okay, so let's create a dictionary with three different interest rates. That's a rate of return you're going to get on your $100. Okay, so let's say you have $100 to invest. Yeah, you have 10 years to invest that money for, and you want to find out at 6%, at 8%, and 10% what would be the values each at every year. Okay, for example, and what will be the final value at the end of 10 years. Okay, so what you do is you have all these variables, you create a dictionary. Okay, so at 6%, so you populate the first value. Now you're going to use that first value to go through that list for the number of years you have. Okay, so for example, we can loop going back to the loop, we can loop through the dictionary keys. Okay, by using wealth.keys. Okay, wealth is the dictionary and keys is the keys you want to loop through. For k in wealth.keys, for k in keys which are contained in wealth, print all the keys. Okay, so you have all the keys. So so this is a list, as you can see. Okay, this is the first element of the list. Now you're going to use that element, okay, which is for I in range 1 to 2 years for 10 years. Okay, so you already have the first year, so 1 to 10. So you want to start with the second year all the way to year. So when it's a year 10, you're basically going to add another 9 years because it will not take that last year, right? That zero based indexing again. Okay, for I in range 1 to 10 years, every 1 year. For k in wealth.keys, if k equals 6%, do this. If k equals 8%, do this. Else do that. Okay, so what changes between these three lines? The interest rates you are using, right, or the rate of return you are using. So this is what you have. So it looks a little bit messy, but you're starting to get a feel that this could have been represented with an Excel or with a data frame, with an Excel type data frame. Okay, and that's what we are going to get into next. Okay, so you're starting to get a feel that these dictionaries are nothing but tables. Okay, so this is one column at 6%. So of course you're going to start off with a year column, year 1 to 10, and then this is going to be another column with this values in that column. This is another column with this values in a column. There's another column with this values in the column, and of course, as you see, at 6% you only have $180 at the end of 10 years. At 8% you have 217, and at 10% you have $261. Okay, so you see the difference as to what rate of returns does, or the rate of return you can get on your investment does to the final value you accumulate. Okay, so we just iterated through keys. You can also iterate through values. Okay, so for v in wealth.values, give me all the values. Okay, so you are basically printing out what is contained for each key. Okay, all the values that are contained for each keys. Okay, or you can loop through key and value pairs. Okay, like this. Okay, so now you're basically looping through everything. Okay, so you're basically recreating the dictionary. Okay, so you're going to say, for I in wealth.items, I want the key first and then all the items in that key. Oh, sorry, the values in that key. I want the key first and all the values in that key, and so on. Okay, so let's have some more fun. Okay, compound interest fun. And I love, especially, I love to play this game with my daughter. You know, I have 2 daughters, and the older one at least gets it, and you know, I keep playing these games with her, right? So let's change this to 50 years. Okay, and you're going to start off with the same $100. There's 3 different rate of return, and you know how the compound interest work, or the math works, and it's pretty astounding with respect to the difference in Well, so of course you're going to do, now you're doing it for 50 years, so it's going to take a lot of space, which it does. So $100 at the end of 50 years at 6% is 1849. Okay, at 8% is 47. Okay, so it's not incrementally more. Okay, so it is actually 3x more. Okay, and at 10% it is 10 times more, or almost 8 times more. So you see that exponential growth. Okay, so this is what we call as an exponential growth rate, and that's what compound interest is. Okay, and you will come across this thing as we proceed, not compound interest as such, but this exponential and logs and all those things. Okay, so not to bore you at this stage, but yeah, so I just wanted to show you this thing. And as you can see, it's very hard to read, so instead, what is the other way we could have done it? We could have plotted it. Okay, and we are going to get to that eventually, where it's hard to sort of comprehend as to what that difference is, as opposed to visualizing all three lines in one plot. Okay, so that's the power of visualization, which we're going to get into later. Okay, and you can also, we went through this looping items. Okay, let's move to strings. Okay, strings are nothing but a sequence of I guess text. It's a sequence of text. Okay, and you can do the same type of slicing as you did to lists and tuples and potentially dictionaries. Okay, so let's say, so you define a string with s, it's a length 35. So if you start from here 0, if it's a 1 2 3 4 5 6, you will count to 35. Okay, so length is 35. What is the 35th element of that list? You think, does that exist? No, it doesn't. Okay, because again, that same zero based indexing. Okay, 34th item. What is the 34th item in that string? It's that last item. Okay, so zero based indexing applies here as well. Okay, so there are some this common method. So you want to replace the so with too much fun. Okay, this is starting to be so much fun. You want to replace that with 2, you can do that. Okay, now it's too much fun. You can convert all of them to lowercase. You can strip this last item. Okay, you can strip anything which pops up in the last item. R strip. Okay, so right strip. Okay, so this thing is gone. If you had this string defined with, say, some common item, which is a question mark. What does it have? Full stop. Okay, and let's say you want to use R strip. It's going to do that same thing. It's going to strip all of them which are here, contained here, and it's going to replace that with nothing, basically. Okay, and you can split that thing into different words. Okay, it splits by the space. Okay, let's quickly cover functions. Okay, functions are nothing but piece of code you want to repeat over and over again. So instead of rewriting it over and over again and making your code extremely long and hard to read, you define functions. Okay, so it starts off with this def kind of definition of a function, and you call this and give it a name. So this function is basically returning a sum of these two values. Okay, so if you don't enter a value for b, it assumes 0. Okay, so that's what, so you can actually enter default values. Okay, so parameters may have a default value, for example. Okay, and indentation, as I said, in Python is very important. Okay, indentation, if you mess around with indentation, it's going to throw an error. Okay, so you want to make sure that you have the right indentation. And of course 4 and 5, it's going to give you 9. My string is, okay, so you print my string is and return 9. 6, it's going to return 6 because the other element is 0, because the default value is 0. Okay, so let's let's do that same compound interest thing again. Okay, so now we define the function. Instead of writing this piece of code over and over again, okay, this code over and over again, you're going to just define a function which does the same exact thing. Okay, so return FV. Okay, so we define a function. Now we're going to say starting with present value of 100. Okay, $100 is the money you start out with. Years is the number of years you're going to invest your money for, and R is the rate of return. Okay, and it's going to give you the final value. Okay, or actually the list. Okay, because you are basically returning a list. FV is a list. You define the list, you append it to that list, and then you return that list. Okay, so same thing. So that wraps up some basic Python review. Now we're going to move on to the actual data analysis and applied data science aspect of this course. Okay, so see you later.